Hey there, so now we're going to be looking at timers. Now, within Python, we have this time library. We've used it before. We actually used it to cause our program to take a break for a few seconds using the sleep function, right? And so now we're going to be using that library to check the value of things. Now, kind of what's going on behind the scenes, we have this time object that is constantly updated. You're going to see what I mean in a second, but it's important to remember that just like anything else, if it's an object, we can call a function on it. And so in this case, the function we're going to be calling on it is time. We're going to be asking it what the time currently is. So let's get in here and actually do a little coding. So we're going to import time, and we're going to print time.time. And let's see what we get. Not tome, time. All right, here we go. All right, that's weird. I don't remember ever having times that were integers with decimal values. That's pretty bizarre, right? It doesn't make sense. It's not something that I would really understand. Well, in order to make sense of it, you have to kind of understand how time works. So the time library is actually pulling down what's called the system time, or what the time is on my computer currently. And it uses what's called an epoch, meaning a starting date that's kind of universally agreed upon, right? And in this case, for Python, the epoch date is 1970, January 1st, at the very beginning of the day. So all zeros, right? So clocks just ticked over. It's New Year's. Everybody's celebrating. Python starts counting seconds, right? And it's been counting seconds ever since. Now, Python wasn't around in 1970, but you get the idea. It's been counting seconds from 1970. So we've had this many seconds, and you'll see that it continues to update. So let's watch these last few digits. So 7495, I've been talking for a few seconds. I run it again, 7556. It keeps going and going and going, right? So all this is doing is counting time numerically instead of in a date format, which makes sense for a computer, right? We know computers like working with binary and numbers and not so much formatted things that people actually read, right? And so for that perspective, it's actually still okay. We can actually take this time and then do things with it, right? So before we do that, I do want to show you what this actually looks like in something we might actually understand. So we're going to use another library called datetime. So we're going to import datetime. Sounds a little more like what we're kind of used to, right? So in this case, we're going to print, and we're going to say datetime dot datetime. I know, kind of weird. Dot from timestamp, and then in here we're going to put time dot time and run. Boom. September 30th, 2021, 1733. That's military time. Subtract 12 is 5:33 p.m. and 35 seconds and some milliseconds thrown in there, right? So it's really, really precise because system clocks have to be. That's how they manage all the processes that are running on the computer. So from that perspective, it actually makes a lot of sense that we have this really, really precise time. If we wanted to format this even more and make it a little more readable, we can even do things like strf time and %c. Now, basically this means format the time as a string, right? And %c is just a special type of format that we're going to use, and we'll see. Let's watch what happens when we run it. Boom. Thursday, September 30th. Even easier to read. And notice it cut off all the milliseconds and everything. It's actually a readable time. Okay, so we can actually format that information, kind of convert it into a date and a time for things like applications where we might want to display the date and the time, like in the bottom right corner of your operating system. So there's a lot of things we can do with time. I just wanted to show you that we can format them. Now, let's look at an example where we can actually subtract time. I know that seems kind of weird, but let's go with it. Start equals time dot time. Okay, so we're going to store time as a variable called start. And then we're going to do time dot sleep. And we'll sleep for 5 seconds. And then we're going to end our time. So time dot time. So what's happening here is we're going to check the time at the start of the program and save it in this variable called start. And then we're going to say time.sleep for 5 seconds, and then end will be the current time after that has occurred. And then what we want to do is we're just going to print start minus end. How long did our program run? We run it. Waiting, boom, 5 seconds. Notice that it's even so precise that we actually have a little bit of variance there, right? So it's pretty much 5 seconds. We'll go with that, right? So start minus end. Why is it negative? Why do we think that's negative? Pause the video, try to think about it for a second. Well, it's negative because think about it. The end time, since it's counting up from 1970, would be a larger value, right? So if we really wanted the actual positive difference, we need to flip-flop this around. End minus start. All right, let's run it. Counting 2, 3, 4, 5. Boom, there it is. Notice again, we had a little bit of variation. That's just the system clock being a little bit off when it's actually catching things. But notice we have a positive number now because end is bigger than start. That's something important to keep in mind, especially if you're wanting to say, wait, until the total program time is 20 seconds before you do this thing in your program, right? So you want to make sure you're actually getting a positive value there. So hope that kind of gets us a little bit into what actually is the time in time library in Python. Next, you're going to start learning how to actually build that into your program and make it a little more intelligent.